last example of chapter 2, 2.1, example 4. So let's take a look at what they're trying to convey to us. So we're finding something called a counterexample, and what that is very simply, it's just one example in which the conjecture that was written out in front of you isn't true. And all you need is one example to disprove it. So to show that a conjecture is always true, you got to prove it. And to show that a conjecture is false, all you have to have is just one example where it's not true and it totally falsifies it. We call this one example that falsifies it or makes it not true, we call that a counterexample. So for inductive reasoning, we look for the pattern, we make a conjecture, so we practice that in the previous examples, and then we prove the conjecture or find the counterexample. Find just one. You don't need to do numerous ones, just find just one and you've got it, okay? So example 4, we're going to practice finding counterexamples. So all these are going to have counterexamples. I'll go ahead and tell you. So be prepared mentally and open your mind to all possibilities. All right, let's look at letter A. For all positive numbers n is any positive number. It could be a whole number, it could be a fraction, a decimal, it can be anything, okay, as long as it's positive. It can't be 0 and it can't be negative, okay? So don't limit yourself whenever you see the words positive numbers. Don't sit there and think only counting numbers, only whole numbers, only positive integers. Don't limit yourself to that. It doesn't say that. It says any positive number, and that could include your fractions and your decimals. And so I would do a couple just to kind of prove it. Say, okay, well, I'm going to let n equal 2. So that would be 1 over n would be 1 over 2 is less than or equal to n, which is 2. Is a half less than or equal to 2? Yes. Okay, so that's true. And that's going to be true for all whole numbers, for all counting numbers. So let's kind of shift gears and let's do n is equal to a half. So we're going to do 1 divided by a half. Is that less than or equal to a half? Okay. Well, you might have, just whip out your calculator, do 1 divided by 0.5, or you could do 1 divided by a half. You could do copy, change, flip. And so 1/2 becomes 2 over 1 when you flip it over. 1 times 2 is 2. So is 2 less than or equal to 1/2? And no, 2 is bigger than that. So here's our counterexample. And that's all we're looking for is a counterexample. So we're going to box that in. This conjecture just simply isn't true. And we found one of the examples, one of numerous examples that disprove it. All right, let's look at letter B. For any 3 points in a plane, there are 3 different lines that contain 2 of the points. Okay, now in a plane, remember, points can be anywhere. They have to be collinear, but they could be collinear. All 3 points could be in the same plane, on the same line, and they don't form 3 different lines. So there's a picture we could draw that shows that this conjecture is false, but that's not necessarily true. That could be true if the points aren't collinear, but that's not what it says. They didn't say anything about being non-collinear or collinear. They didn't say anything about that. So you have to consider that that's a possibility. So this one's a little bit harder. I'm not sure that many people would have thought of that. I think you might have gone with the idea of, oh, they probably aren't collinear. They're non-collinear more than likely. And just remember, leave your mind open for the possibilities. That's not what it says. Those points could be on the same line. And so no, they don't form 3 different lines with only 2 of the points. We can have all 3 points on one line. So that's definitely true. All right. let's see here. Letter C, the temperature in Abilene, Texas never exceeds 100 degrees during the spring months, March, April, and May. So this is where you want to target, it's right here. And so here's our chart. We're just going to use the chart to verify this conjecture that the temperature never went over 100 degrees. Well, guess what, guys? We have a little bit of a problem right here. May was 107 degrees. And you know what? That exceeds your 100 degrees. So that means we have a counterexample. Okay? So hopefully I've clarified some things and made it make sense to you. I didn't have room to put the check it out, but if you have your book, you can open that up and see if you can try those if you want to. I was trying to make it so you didn't have to take your book home, but I just didn't have room to put it on here. So if you have questions, we want to talk about something a little bit more deeply, like letter B, that's fine. Bring your questions to class and let's talk about it.